Hello everyone. In this two-part series, we will go through how to create and configure your app and continuous integration for a continuous deployment workflow. A developer, us, will push our Spring application source code to our GitHub repo. That will trigger the CI to run, which is GitHub Actions in this case. The CI will build source code and a container image. The container image will then be pushed to our private Docker registry in the Kubernetes cluster. Then the application deployment files for Kubernetes are generated and pushed to a separate GitHub repo. Within a couple minutes, Argo CD will realize there are changes for application, and it will deploy the updates using the rolling update strategy. If there is a change in the container image to be used for the deployment config, it will pull from the private container registry. We also create an Ingress which uses the Cert manager to automatically request SSL certs from Let's Encrypt. Our Ingress then uses the trusted certs. A user can then access our application via the Ingress, and the traffic will be encrypted using SSL certs. One thing to note is that we use two different Git repos for this approach, and the reason for that is to enable us to configure our deployment configuration without having to make source code changes. For example, if you want to scale the number of pod replicas, you can update the config file in the GitHub's repo only, and that will propagate to the cluster via Argo CD. I created a GitHub repo with all the necessary steps and templates required to set up your Kubernetes cluster. You will need to install kubectl, Digitalocean CDL, and Helm. You need to own a domain, and you'll need a Digitalocean account to follow along. You can get $200 free credits if you sign up to Digitalocean using the link in the description. Once ready, download the repo and open a terminal to follow along. The first thing we need to do is create the Kubernetes cluster. In Digitalocean, navigate to the Kubernetes page and click Create Cluster. For the region, I'll choose London. The version we'll leave as is. For the scaling, we'll leave it at fixed size. Reduce the number of nodes to 1 and select the $18 per month node plan. You can give your cluster a different name if you wish. And lastly, select the project and hit Create Cluster. It can take around 5 minutes for your cluster to become usable. You may need to refresh the page a couple of times. After a couple of minutes, you can press the Get Started button and copy and execute the command to authenticate with your cluster. Afterwards, any kubectl commands will be run against this cluster. Back in Digitalocean, press Continue until the Getting Started section disappears. Alright, now back to our cluster configuration. We will install the Nginx Ingress load balancer. This will allow us to access our cluster application from outside the cluster. So what you need to do is decide on a host name to use for your load balancer and set the value in Nginx Ingress values.yml. In my case, I own the codingwithmax.com domain, and I want to use a subdomain for my load balancer, so I will use lb.codingwithmax.com as the host name for my load balancer. Let's go over some of the values here. We configure our Ingress controller to have a replica count of 1. We set some requests for the resources, meaning that if the node doesn't have the requested resources to allocate for this pod, the pod will not be started. Next, we set the service type to be a load balancer. Then we have some annotations. Enable proxy protocol means that the original client IP will be passed down to the application. Otherwise, the client IP making the request will always be set to the load balancer IP. TLS pass-through means our load balancer will pass the TLS requests straight to the application, without decrypting the traffic first. And then we configure our load balancer with the host name. The config section here controls the Nginx configuration. Again, we set the proxy protocol to true and configure a few other properties. Next, use Helm to add the Nginx Ingress repo. Then update the repo. Then install the Ingress controller, passing in the namespace and the YML file. The create namespace flag creates the namespace if it doesn't exist. Once the Ingress controller is installed, Digitalocean will create a load balancer that will direct traffic to all of your node pools. Note, the load balancer is not free and will incur a charge of $12 per month. Now navigate to Digitalocean, and in the Cluster Resources tab you will see a load balancer is being created. Click on the load balancer and wait for it to finish creating. Once created, you will see the IP it is assigned. Now we need to add the subdomain record in our domain. I'm using Namecheap. If you're using something else, navigate to that website and go to the page where you modify the host records for your domain. We will be adding an A record type. For the host, enter the subdomain part, in my case it's LB, and for the value, enter the IP address of the load balancer. With this in place, when a request is made to lb.codingwithmax.com, the request is directed to the specified IP address, which is the load balancer for the cluster. I will also add a second A record for the subdomain with the www prefix, pointing to the same load balancer IP. That's the load balancer setup finished. To verify the configuration, in your browser, navigate to the new load balancer domain, which in my case is lb.codingwithmax.com, and you should be presented with a 404 error from Nginx. This is a good thing because we know our request reached the Nginx controller in the cluster. Next, we will set up the cert manager and cluster issuer, which will be responsible for issuing trusted SSL certs for the ingresses you create. It will also automatically renew any certificates that are about to expire. The first thing we need to do is set a valid email address in the certissuer.yml file. Then use Helm to add the jetstack repo. Then update the repo. Then install the cert manager in the cert manager namespace. And lastly, create the cluster issuer that will be used to issue and renew certs. Next, check the pods in all namespaces and we see a few cert manager pods running. That's the cert manager done. Next, we'll install the private container registry. For the container registry, we will use Digitalocean spaces as the backing storage for the container images. First, we need to decide on a host name to use and update the domain host records. I'll be adding a new subdomain here, and this time I add a CNAME record with a value of registry.1, and this will point to the load balancer domain. If our load balancer IP ever changes, all we'll have to update is the load balancer record. All other subdomains pointing to the load balancer domain will remain unchanged. I'll add another CNAME record for the www prefix. Next, we set the hostname in Docker registry values.yml. We have three main sections in this file. The first configures the ingress through which our container registry will be accessed. We specify the hostname to use for the ingress, the cluster issuer we created earlier to issue certs, and the TLS section configures the secret in which the generated certificate will be stored. The secrets section defines the username and password that will be used to authenticate to the container registry when pushing images, and the access key and secret key are used to authenticate with Digitalocean spaces to store the image files. Lastly, the S3 section defines details about the Digitalocean spaces bucket where image files will be stored. Alright, with the ingress configured, we now need to create the bucket in Digitalocean. Head over to Digitalocean and click Create and Spaces. Choose a region for your bucket and give it a unique name. The name you set here will become part of the URL used to access your bucket. And finally, click Create Spaces Bucket. Copy the origin endpoint from the top right and set it as the region endpoint, but leaving out the HTTP protocol. Set the region, you get the value from the endpoint, and set the bucket to the bucket name. I would like to pause here for a moment. I realize I made a mistake with the region endpoint. The value of the region endpoint must not contain the bucket name, so make sure to remove the bucket name from the endpoint. Alright, now back to the tutorial. Next, we need to create an access and secret key. In Digitalocean, navigate to Spaces and in the top right click Manage Keys. Scroll down to Spaces Access Keys and generate new key. Give it a name and click the check mark. Next, copy the access key and set it in the YML file. And do the same for the secret key. Next, we need to generate a username and password used for authenticating to the registry. We'll use a Docker container to generate the HD password file. Before running the command, replace myuser1 and password1 with your desired username and password. After you run the command, a HD password file will be created. Print the contents of the file and copy them. Now open the registry YML file and replace username and password with the contents of the HD password file. Now we can create the registry. First add and then update the Twony repo. And install the Docker registry in the Docker registry namespace and passing in the Docker registry values.yml file. Next, list the pods in all namespaces and we see the Docker registry pod running. We can also check the progress of certificate generation by listing out the certificates. We can see we have a certificate for the Docker registry and the ready flag is set to true, meaning it is being used by the Ingress. To check details of the certificate in the browser, navigate to the registry hostname and inspect the certificate. So that's our private registry set up, but before Kubernetes can pull images from this registry, a special secret needs to be created with authentication details. The most important part is to create the secret in the same namespace where your Spring application will be running. We don't know the namespace yet, so we will add the secret at a later stage. Next, we'll install Argo CD, which is used for continuous deployment of our application. Again, the first thing to do is set up the hostname. I'll be adding a new subdomain called Argo CD. So I'll add 2 CNAME records in my domain, pointing to the load balancer domain. Next, set the hostname in Argo CD Ingress http.yml. Then create the Argo CD namespace. Then install Argo CD. Let's list the pods and add the -w flag to watch the resources. This will print out any pod updates. Wait until the Argo CD pods are running. I'll list out the pods again a couple of times to confirm all are running. Then create the Argo CD Ingress. Now list out the certificates. The Argo CD Cert is not ready yet, so I'll watch the certificates using the -w flag. After a short while, we see the Argo CD Cert is ready. Before we can log into Argo CD, we need to get the admin password. Execute the command to get the password. And then navigate to the Argo CD hostname and log in with the username admin and the password you retrieved. And we're in. Thanks for watching and see you in the next one.